Dimensional formula. Nobody would be asking you what is dimensional formula. But people may ask, write the dimensional formula for force, pressure or strain. I don't know. Question papers may ask what is dimensional formula.
Don't follow me blindly, I may be deceptive.
So to derive dimensional formula for quantities like force, you need to know about some fundamental quantities, or you can say basic quantities. There are 7 basic quantities which are mass, length, time, temperature, electric current, luminous intensity and amount of substance. Dimensional formulas mostly use MLT, which is mass, length and time. So let's see how to derive these formulas. First physical quantity is velocity. If you would have paid attention to your grade 9 online classes, then you would be knowing that velocity is displacement by time and its SI unit is meter per second or ms per minus 1. This is also meter per second. So to write the dimensional formula for velocity, we would be first using the square bracket.
As meter is the SI unit for length, we can write L raised to 1. And second is the SI unit for time, and time is represented as T. So we can write T raised to minus 1. And as there is no mass, we can write m power 0, close the square bracket. And that's the flawless velocity formula.
Let's move on to acceleration. Acceleration has the formula velocity by time. And velocity can be written as displacement by time. And this time can be written as it is. So if we further calculate, we get displacement by time square. It has the SI unit meter per second square or ms power minus 2. Now this would be a quick one. M is length, L power 1, S is second, T power minus 2, and there is no mass, so M power 0. Let's take some other physical quantities like force. Force has the formula mass into acceleration. We can write mass as M and acceleration as Lt power minus 2. So if we multiply M and M, we get M power 1. So the dimensional formula for force will be mLt power minus 2. If we take another physical quantity like work, it has the formula force into displacement. You can just write the dimensional formula of force and displacement individually and then sum it up. Like force has the dimensional formula ml t power minus 2 and displacement has the dimensional formula L. So it becomes ml t power minus 2 into L, and if we multiply L and L we get ml square t power minus 2. If we take another physical quantity like kinetic energy, which has the formula half mv square. Half is a constant, so it has no unit. M is mass, so we write m. V square is velocity squared. Velocity has the dimensional formula m power 0 L t power minus 1. So we write it as it is, m power 0 L t power minus 1 squared.
Just use an exponential identity and solve this bracket.
And if we just multiply m and m, we get m L square t power minus 2. And that's the dimensional formula for kinetic energy. But as you can see, the dimensional formula for work and energy is the same. So we get to a conclusion that
Quantities may have the same dimensional formula, but they may not be the same. For instance, as we have seen before,
the dimensional formula for work is equal to dimensional formula for energy, but work is not equal to energy. A physical quantity angle with formula arc by radius has a different dimensional formula. Arc is measured in length, so we write length, and radius is also measured in length, so we write L power minus 1. These two cancel out each other, giving rise to dimensional formula m power 0, L power 0, T power 0. So this type of formulas with no physical dimensions are called dimensionless quantities. So this was a basic overview for deriving dimensional formulas.